So you want to build a PYSAPIEN. This guide will show you how to do it. You can start by 3D printing the mid-frame of the robot. You can use the original frame of the robot, but this 3D printed frame is going to give you a much better time. You know, it has holes for wire management. So once that's done, you can start putting components on it. And speaking of components, here are the components that you're going to have to get online from Amazon or AliExpress or something, I don't know. Okay, so you'll start out on the website, and there are a few things you'll want to download. Now, the download links aren't completely updated yet, but if I go to the downloads, go to PYSAPIEN, there's the video build guide and some basic programs, and there will be PYSAPIEN OS Axon, and you can download that. That's going to be the latest version of PYSAPIEN OS. It'll either be 0.9.8 Bridgeway, Mach 4, or it'll be OS 10 Axon. So this changelog has basic G2 feature support. It shows you some issues as well. And then there's the PYSAPIEN control application. You're going to want to download that on your Android phone. And it'll be like, oh no, security and whatnot, but I promise you I'm not trying to like explode your phone. It's just, you know, a control application that controls the robot. And then you'll download PYSAPIEN Companion and PYSAPIEN Emulator that runs on your computer and allows for you to do the AI roaming by running a server on your computer. And then you'll download something called Ollama. I'll add a link for that, but the purpose of Ollama is it allows you to run large language models. So if we open Ollama right here, you can see I've already selected GPT OSS 120 billion parameter cloud. So if I say poop fart, it'll be like, oh yeah, okay, I'm thinking, and it says it seems you might have been, you know, like sending that by accident. So that's your large language model engine. Now in the future you will have specific builds for specific boards like the Raspberry Pi or the Radza QB-A7Z, but right now this is just a Raspberry Pi build. It might not even work right now, to be honest, but I will try to change that before I upload the video. So once you have all that software installed onto your computer for the specific computer that you need, you'll go to the build guide and you'll click here, and it'll tell you that you need to get this time of flight sensor, some batteries, battery connectors, a speaker, a Bluetooth circuit, motor drivers, positive contact foot relay, and then your INA 219 USB camera, IR or fisheye aperture 2.0 lens, servos, barrel connector for the foot 5-volt system, or you can use USB-C if you want to. Button board, PWM board, cooling fan, high gauge wire for battery connectors, low gauge wire for computer and everything else. Toggle switch used for deep cycle switch, so if you're not going to use the robot for a while, you can turn off the relay in the foot. And then you have a copper tape spool for the foot connectors on the robot that connect it to its dock, and you can also put that copper tape on the dock and 3D print the dock as well. And you can just get like a good cheap SD card at Walmart. I don't see the 5-volt board here, but I will add that here in a minute. You'll have to stack two 5-volt boards together, and we'll get back to that in a minute. But you'll order these things on Amazon, or basically the same thing somewhere else in a lower quantity for cheaper. It really doesn't matter where you get it. It's just if you get it on Amazon, you get spare parts that you can use for other projects and backups. Usually it comes in larger packs because you have to order in bulk, but you do pay a premium for Amazon, just to be clear. You could get it on AliExpress for cheaper, but it'll take a very long time to get to where you are, and if you live in the USA, I can't guarantee you'll even get the parts you need. I feel like it's also worth mentioning you'll be able to download the 3D model files from the website, but as you can see right here, this is the 3D printed frame, and if you have a smaller build volume printer like I do, you'll be printing it in multiple pieces. As you can see, they just print in interlocking patterns and they screw together. I kind of screwed up here because the back plate is supposed to be cut differently than the front plate, but I mean, whatever, it worked just fine. So your 3D printable frame will either come out in 4 or 8 parts depending on how big your printer is. So mine is 8 parts, I'm gluing it together as you can see right there, and I'm just going to spread out the glue nice and good because we want tons of structural support. So once I get that front shell done, we're going to get the front plate, and put it down onto the front shell. So there you go, I'm going to line it up, and it's going to be kind of hard to get it to stay, to be honest with you, but it will do it eventually. So there you go, that's a completed G2 frame. Now, some things did fall apart while building it, but I'll fix that with the revision 1.3. Now you'll want to take a PCF8574 GPIO expander and trim it down and add I2C wiring to it. And you'll also set it to address 27 and remove everything else from the board so it'll fit. So now you'll want to take that modified board and adhere it to the part of the frame that says PCA, and that's where the expander goes. So you'll add 2 wires on the top, and I'll show a schematic on screen right now that shows you how to connect these things. And these pink wires are going to go to the limit switches. One will snake in front of the vent, and the other one will snake through the vent directly to the left side limit switch. So whenever we put it together, you'll have an orange wire as well for every pink wire, and that's a button signal. So you can see we have an orange wire and a pink wire routing through each and every corner of the frame, and that's for the buttons and the limit switches. And we also have 3.3 volt wires and those 2 orange wires coming out of the back going to the feet. But the feet only has 2 button signals because there's no limit switches. So this is your INA 219. You'll need to remove the screw terminals and any shunt that may be installed onto the board because we're only reading voltage, and the code has been adjusted to read without the shunt. So we'll connect that to the I2C system, remove the screw terminals, set the address 0 pin, and remove the shunt, and everything should work just fine. And we'll also need to connect it to the voltage input from the battery system to monitor the voltage of the robot. So you might want to wire it together a little bit better than this, but now it's time to turn our attention to the 5-volt boards. So you'll have 2 of those 5-volt boards trimmed down and turned into a sandwich with an insulative layer like this. So you get one 7.4 volt input for 2 5-volt rails. So once you snake the 7.4 volt wires out of the back so you can connect it to the battery system, you're pretty much done. You have a mid-frame of a PYSAPIEN. Now it's time to turn your attention to the front of the robot, where you'll have to route the 5-volt connection from the secondary 5-volt board to this PCA board right here, and you'll also have to remove the pins on it so you can solder the wires directly to it, which is a common theme here. So you start out with a normal I2C connection, but then you tie the grounds together and add a 5-volt connection to the V+ pin, and that should allow you to use those red and black pins to power extra 5-volt accessories off the secondary 5-volt lane. You'll take those yellow pins and connect them to motor controllers accordingly. I'll show a schematic on the screen. So you'll connect these 3 motor controllers up like that, and you'll also have a red and black wire routing through the frame for each of them that'll join together and power those motor controllers whenever you put it together. It's also a really good idea to give everything a once-over with a multimeter at this point, because everything will explode if it's shorted. I'm going to go ahead and put a pinout on the screen so you can follow this at home, but this is an 8-pin arm connector, and the 8-pin arm connector connects to the arm to make everything easier to put together and take apart and modify. So you have a 5-volt connection going to the secondary 5-volt board with the ground going to that as well. And then you have the PWM signal and the motor signals, so we'll just add in some purple wires for the motor signals, and we'll deal with those later, and a yellow or orange wire for the PWM signal. But other than that, you just hook up the limit switch to button 2, and you connect the fingertip button to button 1, and then you connect the 3.3 volts to where it goes and the 5 volts and grounds where they go. And then you have motor A and motor B. We'll worry about PWM, motor A, and motor B later. Again, you can see some meticulous testing with the multimeter. This is a very good practice when building a PYSAPIEN if you don't want to make a big expensive oopsie. So we'll just copy the arm connector on the other side and do some cable routing and pass those PWM wires through the back. and we'll keep those other purple wires ready to be connected to the motor controller. But for now, we're just checking for shorts and putting together the connectors and making sure that everything goes together properly. So I thought I would stop here with the voiceover and actually explain as I'm working on the thing that I'm building to confirm what you should have here. So you should have two 8-pin arm connectors following the standard pinout. I know there's no hand LEDs yet, I'm working on that. You should have the 7-volt input right here going to these two 5-volt boards. And you should have these two 5-volt boards outputting separate 5-volt rails. One goes to the computer and one goes to the rest of the components. You should have just one 5-volt line going out towards the front, and we'll later connect that to the front plate. You should have the motor A and motor B connections, and in this case it's indicated in motor A being bright purple and motor B being this dull purple. I've got that going on over here as well, and this one doesn't have the limit switch connected yet, which is indicated in pink and green for the voltage, and they're polarity blind. It doesn't matter how you hook them up, of course, to switch, but this one is connected, and that's basically how it should look when you have a limit switch connected. Coming out of the rear of your robot, you need to have a voltage input that supplies power to the entire robot from the battery system and also reads that voltage. And then you need the PWMs that go to the single board computer. You need SDA, SCL, and all the I2C stuff. So here's that. We'll go ahead and grab SCL and then ground. And all of these will basically hook up to the I2C pins. So that's what those 4 wires do. And then we have these 3 wires, a little brighter green, and that's a 3.3 volts for the feet, for the buttons in the feet to work, and these orange signals are actually the buttons inside of the feet. And over here we have the 5-volt system that connects to the computer, and right over, well, I think that's actually it. Is that it? Yeah. Okay, it's more simple than even I thought it was. Now, as for the front plate, you should have this cloned right over to here with 2 wires, and this right there, and that right here. It's in exactly the same order. This is the first pin right here, this is the last pin right here, and vice versa. And then you'll have all of these motor controllers going through slightly beefier wires, and that'll meet together, and we'll later connect that to the battery voltage. But basically, this is kind of what you should have right here. I know it looks like alien technology, but it'll make sense here in a minute. Now, I hope that you've been keeping track of your wires, because if I didn't know what any of this was, I'd probably be freaking out. Now you'll pass the motor controller power and I2C wires through that back slot as well, and you'll put the front frame on and start screwing it together. Now be careful, or else you'll break the screw posts like I did, because I'm an idiot. Also, maybe try heating up your screws if the tolerances are bad on your 3D printer. Also, be sure to pass motor A and motor B from the arm connectors to the front. Stoot! Hello, cat. What do you have to say? Stoot, what do you think about the robot? You just gonna sit here? Just gonna sit here, Stoot? Yeah? Goodbye. So now it's time to wire up the motor controllers on the robot. Now you can see on the Robosapien motors, there's a resistor that's closer to the front plate and a resistor that's further away from the front plate. Now what you're going to do is you're going to take that resistor and you're going to connect the one that is closer to the front plate to the left pad on the motor controller. And then you're going to take the resistor that's connected closer towards the back of the robot and connect that to the right pad on the motor controller. And you're going to do the exact same thing on the other side. Now if you do this correctly, your motors should move in the right direction without having to mess with the motor config. But you can mess with the motor and button config just in case you accidentally mess any of this up. Now inside of the feet of the robot you'll find a relay that connects to the positive side of the 7.4 volt batteries, and you'll have one of those batteries in each foot. And you also have a speaker in each foot, and this little switch right here, this switch turns on and off the relay. You don't have to add it, but you can if you're going to store the robot for a long time, to prevent the relay from draining the battery, of course. There's that speaker, and that relay actually routes to a copper plate, and that's a positive battery terminal, and it's not always on for obvious reasons, but it connects directly to the battery system. In the other foot you have a 5 volt balance charging board that balance charges one of the batteries, and the other battery is always connected. Then you have a 5 volt barrel jack or USB Type-C connector to activate that 5 volt charging board, and you also need to Dremel out the front of each foot. And if we look at how the robot attaches to those feet, you'll see there's button lines, and then there's a 7.4 volt line coming from the batteries that's tied together, and then there's the speaker lines. You can have stereo or mono. The only difference is the wires will join together if you're using mono audio. Now this is the actual process for putting the robot back together. You screw in the hips, as you can see there. So now we'll go ahead and connect the orange button wires we have for the feet to each foot, and we'll also connect the 3.3 volt line to each of those buttons so the buttons function properly. And we'll also connect the 7.4 volt system to the batteries if you're sure that nothing is shorted, and connect that 7.4 volt positive line to a switch on the back. You'll also need 2 wires coming out of the back that connects to the batteries as well as the 5 volt board, and that goes to the motor controllers so that you can later take apart the robot. And we'll leave the I2C alone for right now because we need to build the head of the robot, which also ties into the I2C system. But you should have 2 pairs of I2C wires coming out of the back of your robot at this point. Good news though, if all went according to plan, you have a fully functional PYSAPIEN frame. And all you need to do is add the computer on the rear and attach the rest of the systems, but first we need to build the rest of those systems. So the last step of building the robot will be putting the body onto the bottom half of the robot. You have to screw in these screws right here and make sure that the spring is resting on the plastic like this. Both screws need to be exactly the same or else you'll have some problems down the line. You should have your power lines coming together and going to a switch on the back that goes back into the rear of the robot to power all the systems off the 7 volt. You should have the button lines for the feet. 2 of them share a 3.3 volt connection, and the other 2 run back to your GPIO expander. And then you've got this speaker wire, so you have stereo audio coming out of the feet if you configured that, but I mean, audio is really something that you can do whatever you want with in PYSAPIEN. I just recommend putting them in the feet. For instance, you can see I'm going from stereo to mono because I'm using a garbage audio driver, but I guess it doesn't matter. Now we will turn our attention to the PYSAPIEN servo claw, a mechanism most terrifying. Basically what you're going to see if you open up a PYSAPIEN servo claw is the original movement has been removed, but I don't recommend snapping that rod. It was unnecessary and causes issues down the line. You'll find that everything has been rewired, and the original board that everything went to has been removed, and the front of the claw right here has had a lot of structure removed, so we could fit a servo in here, and the bottom of the servo has been removed and it's adhered to the gearbox. And then you've got a servo arm over here with copious amounts of adhesive going to this metal rod that is embedded into the Robosapien claw.
and that allows for it to actuate the claw. Now, of course, it can't pick up things that are really heavy, but it's more for show. It's a cool thing to have. Again, that's the gearbox and the original hand movement removed, some material removed, so you can run this rod right here. You have to remove a screw post right there, and that's actually, I found it to be more of a feature instead of an issue, because the claw's structural integrity is still good, and if the robot turns off, you can stick a screwdriver in there or something and push this back to close the hand. You really don't want to be forcing it open and closed because of the way it works. PYSAPIEN's kind of, limited. He's not perfect, obviously. And you remember those 8-pin arm connectors from earlier? You'll have to recreate that on this right here so that you can easily attach it to the robot. That's why I stressed so hard about the 8-pin arm connectors. It's a nightmare without them. So now all you have to do is line up the arms with the limit switches inside of the frame, like so, and then you'll grab your arm and then attach it, and it should look something like this if everything went right. There you go. Well, nice. I haven't screwed it together yet, but yeah, you get the idea. So, assuming you've got the SD card flashed and everything, you can go ahead and try to give it a power on test. It might take a minute the first time. If nothing explodes, that's actually a good sign though. We've got life. There you go. You should see something like this if the robot is starting up. And then you'll go through the first time setup process, but we can go ahead and turn it off. It's running PYSAPIEN OS Axon and everything is detected and working properly. If it's not, you'll get an error code. So we'll install Robosapien's arm bushings back onto this third-party frame. It could take some persuasion. So we'll line up this bump with the limit switch, and once we do that, we'll go ahead and take our arm and put it on there. Like so, and that looks correct. It could take some persuasion, but once you get the arm pieces on, you can fit these springs over them. So you're going to have to find where they rest and put them where they belong. And they go back to these little screw posts where they attach to the robot's frame. So once you have the arm in the correct position where it's on the limit switch and the spring looks like this, you'll go ahead and cock it back and then install it like this. Now, as for PYSAPIEN's neck mechanism, it's just a piece of fabric that has some Velcro inside of the robot, and that's so you can later get to the ports on the back of the single board computer. We'll get to that in a second, but as you can see, you need to trim it up a good bit so that the servos have some space to move, and the head has enough room to move around as well. The main reason the gap is so large is the robot needs to have adequate space for the head to pan around. Here's that rear feature of the robot where you'll be able to push the head down, and because the single board computer is upside down, that does mean you have to open up the robot to access GPIO pins, but what you don't have to open up the robot to access are the ports on the single board computer. And in the case of the Robosapien A7Z, that also means you have that little exposed PCIe connector right there. Not sure what you're going to do with PCIe in PYSAPIEN, but if I were to guess, since his firmware supports NVMe right now, you could make him start up a bit faster and use the OS drive as a scratch drive, just like it does with the SD card, but probably feasibly run large language models off of it and buy models with less RAM. But of course, you're probably using the Raspberry Pi Zero 2W, which is something that I still have to put together in terms of software support. Trust me, the Robosapien A7Z is giving me a PWM development nightmare. So if you're using a Raspberry Pi, just route all the servo PWMs to the rear of the system, and some of them already run through that by, the whole wiring we did in the mid-frame. But you just need to make sure that you put it together properly. I mean, that's the whole thing about PYSAPIEN. Meticulous multimeter testing, this thing exists by the seat of its pants. Now, PYSAPIEN's head is something that seems a lot more tricky than it actually is, because if we pop it off of here and take off this back plastic, if you look inside of the robot's head, you'll see the SPI wiring that goes up to his face, and that's how the display works. It's remarkably simple. You have some borders around the screen if you have the time to make that and make it look nicer, but the display just goes where some old structure used to be and you adhere it down. Now, as for the depth sensor, that's a little more advanced. What you've got going on here is a VL530X distance sensor inside of the head, and it has to be trimmed down. Well, it doesn't have to be trimmed down, but the robot's going to look better if you trim it down, and then put a little piece of plastic or vinyl over it like I did. Now, if you want to use the original Robosapien mouthpiece and use a light pipe so that you don't have to have the face of the robot modified too much, just keep in mind the code will have to be adjusted so that the light pipe is reading at the correct angle. The way PYSAPIEN works is he has two modes: an angle that you can configure in settings where he can measure the distance between him and objects, so that's whenever he's observing something and trying to learn about it, or just looking straight at something. So he'll like, okay, there you are. And as for the way the head attaches to the servos, just make a river of adhesive and melt it into place so that it never comes free, and cut a notch in the back of the head. But don't go through the plastic, that'll compromise structural integrity. So that gives you a head that is fully actuatable and actually quite stable. Unfortunately though, a lot of Robosapiens won't take so kindly to you busting the head open. Only the newer ones seem to do really well with that, because the old plastics like to shatter and they adhered it together. So if you accidentally blow up your head, don't worry. I have other 3D printable heads on the internet, but you know, it's like a little funny square robot head, like a cartoon robot. I'm not sure if it works really well. I haven't tried it yet, but it should be about the same size as Robosapien's head, so if you end up with a block-headed PYSAPIEN, I'm sorry, but don't say I didn't warn you about that plastic head. I'm currently working on reverse engineering PYSAPIEN's head, but I'm also reverse engineering my door handles in my car so that I don't have free-floating straps sitting there without explanation. It's a Sonata, okay? The door handles break. I'm gonna replace it with straps, not handles. It's fundamentally flawed. So once you have your audio solution and you've tested the robot and it boots up and all that good stuff, you can start screwing the pants back on. And the reason the ones on this robot are so wide is because the earlier versions of the robot had really bad hip clearances, so that messed things up. But yeah, I mean, it shouldn't look like that. Now you'll have to connect this 5-volt fan in the rear to the rest of the robot, and if we turn it on, you can see everything is functioning the way that it should. Except my speaker came unsoldered, so let me go ahead and fix that right quick. Actually, before I fix the speaker system, I thought I should tell you about how you have to modify the shell. Now you can see in the rear we've removed a lot of that speaker grill mechanism so that we could fit a fan, and that takes fresh air in. It doesn't have to glow, but later versions of the robot will support PWM fan, so the fan glows in sync to music, or when the robot looks like it's breathing while idling. I mean, I don't know, it's pretty cool. And the robot also sounds like it's breathing. But that's neither here nor there, that's not programmed yet. For the camera, you just need this little USB guy, and you drill a hole in the front and keep the microphone holes open so that you can get some audio going into the robot. He'll hear you if you go right up to him, and I think it's honestly best that way. But most of the time he hears woo. I mean, he's like a miniature server. Speaking of miniature, guess what I just got this Christmas from my brother? I got mini Robosapien. Oh yeah, Christmas happened. Let us activate him. Come on now. There we go. Look at him go. Oh, I love this. That gets PYSAPIEN too. Ah, there we go. Hell yeah. Maybe it's best that this thing's remote controlled. But I could see, like, giving it a better remote than this. Now, I still need to do a few things for my PYSAPIEN, but you might feel, once you put it together, it's a little bit stiff. And I know it feels wrong, but you're going to have to grab the arms, and with a good amount of force, just start flexing it in and out and up and down. And this will break in the 3D print so the robot's arms are loose. It's like this, so it works on pretty much any 3D printer. And then you'll notice it moves perfectly. I mean, at least it should. If it's not moving good, something went wrong with your 3D print. But look at that. But this is pretty much a PYSAPIEN. If you're at this point, you have essentially constructed the entire robot. So we'll proceed from here. Now, there's one more thing you're going to have to do for PYSAPIEN. You're going to have to find a way to route that USB 2.0 bus from the camera to the inside of the robot, and you need a right angle connector that is short enough for the servo to clear it. So when you install the computer, make sure that there's enough room for that adapter. If there's not, then you can download a different 3D model with adjusted screw posts. Just contact me about it. Again, the project is good in theory, but there's not field testing, you know what I mean? So I don't have that adapter yet, but once I do have the adapter, this USB camera goes straight into the back of the robot and over the frame right by the side of the servo where there's nothing over on this side, and there's all the SPI and I2C wires coming up from the main board. That's where you're going to run your USB connection through the frame and to the back and to this USB connector right here to avoid interference as much as possible. If you can't tell by this point, neck jitter is something that I have fought very meticulously and won the battle with. Usually if you have neck jitter, it's because your head is trying to fall apart and you did not put it together properly. Or your servos inside of the frame itself are loose, and mine also has that problem. So when your PYSAPIEN's here, you can turn it on and begin operating it. Now mine has a number of problems, like the 8-pin arm connectors. The 8-pin arm connector used to be mirrored on the other side, just not an exact clone in the last revision before I made the build guide. Then you'll hear a click and PYSAPIEN will begin loading. Now don't start him up on a metal surface for the first time, because that click is his relay engaging for his charge gate. And since he's not really good at moving right now with this current version of the firmware, until you don't hear the click, the motor control system is still under maintenance. And the reason you'll hear the click is I'm actually putting the robot onto its charging dock while messing with the code to make sure in real time that I've made good adjustments. Now, PYSAPIEN's going to take a very long time to start for the first time, and that's because you need to download PYSAPIEN Companion on your computer and click the AI Server button and click Start LLM Server. Now, it's not going to do anything the first time because it doesn't know what address your computer is, but you can change that in the settings of PYSAPIEN Companion and PYSAPIEN himself. It could take minutes for this first boot up and any other boot up where it's trying to ping an IP address, especially if it pings the IP address and it is something, but it's not the computer it was looking for, which is what it's doing right now. Because PYSAPIEN Companion wasn't open when the robot launched, it's a bit strange. Now, this Python socket thing will be changed in the future to something that passively connects and disconnects from the computer on its own, but again, this is a very early version of PYSAPIEN OS 10, so I wouldn't expect too much from the robot right now. Just give me a minute to button up the software. So the robot will start doing the first time setup animation, and then you'll enter the settings and connect him to a Wi-Fi network by pressing down both of the hand triggers. Now I wish I could show you how to do this right now, but just wait for the robot to reach its idle state and then hold down both of the finger triggers and it should work. Now we're lacking the first time setup process right now. So I'm really trying to rush this version of the operating system out the door, but I will upload a video in the future explaining how to set up PYSAPIEN whenever it's more buttoned up. Right now, I'm just trying to make sure that the people that have PYSAPIEN have a working robot. As you can see, he kind of works properly. We've got some servo control going on there, but his drivers are still a bit strange. But he mostly moves properly. You'll download the PYSAPIEN control application, look at the IP address of the robot, and then enter it and do all those things that you need to do. PYSAPIEN Companion on your Android phone should really walk you through what you need to do, but I need to download an update. So again, in terms of software, the software is going to be very buggy. It's still really early, but I uploaded this video in the state it's at right now, so that if anyone has any complaints about the build guide, they can email me. You can look at my website. There's all sorts of resources. You can download all the stuff, purchase all the stuff on my website. All that's going to be linked below. Or you can also personally call me by contacting me, and we can do like a Google Meet or something. If your PYSAPIEN isn't working right, you don't have to show me your face or anything. Just like show me, hey, this is what's wrong with the robot. Oh, whoops. And I'll be like, ah, yeah, you did this wrong. But there's also an error codes section of the website I'm working on right now. This is just the very early days of PYSAPIEN making his way out. Anyway, we know that the robot functions. Mine has a few problems that I need to iron out, like this USB connector and these arm wires. And I think this arm as a tight spring. I may have put a bad spring in that arm, to be honest with you. But other than that, your robot's ready. That's what PYSAPIEN is. This is PYSAPIEN, and I'm so glad that you guys can finally enjoy him. Just stick with me here while I patch up the software. I had a bunch of life stuff going on, got a partner, spent Christmas with them. I'm not trying to give you my whole life story, but a bunch of events happened that I did not foresee, and I was held back from finishing the PYSAPIEN build guide. This was really filmed over the course of a couple of weeks. And it's not like it had to be, it's just that I want people to understand that I'm a remarkably average guy. Expect good updates and support on PYSAPIEN, constant manipulation with it, a good community. The GitHub with a software store is something that's coming out very soon. And PYSAPIEN OS 11 Bion already has plans to split everything into multi-processing so that it runs faster. So of course, it's gonna get support, but I'm a human, just like you. I mean, if you were messing with technology ever since you were 8 years old, you'd probably do something similar. I'm no more capable than you are, just obsessed and very autistic. And most people who mess with Robosapien have a hint of the tisms, I'm not gonna lie to you. I've seen all your videos in the Robosapien community, basically. Where do you think I got the idea to finally go through it with PYSAPIEN? That one guy that made this, like, safety crash dummy Robosapien, honorable mention, that's really cool. This guy that made the WISE project actually talked to me in my first video that I uploaded on PYSAPIEN, and I also thought that was really cool because WISE was a very big inspiration for how cognitive PYSAPIEN is.
21,196 km.
What's the diameter of Jupiter?
85,964 miles.
How's your day going?
My day is going great, discovering new things. Exploring is fun.
Robot, can you move your arms around for me?
I can move my arms around for you. I can give basic tax information, but I can't file returns for you.
I tried to make PYSAPIEN think as much like a human as I can. The Robosapien community is absolutely awesome, and I'm glad to be a part of it. You guys keep doing what you're doing, because I am silently in the background checking all of it out, and I think that the people out there that do stuff with Robosapien are just as cool as I am. Maybe I made PYSAPIEN, maybe PYSAPIEN's completely insane, maybe PYSAPIEN's not even Robosapien anymore to an extent, which is something I have to say for legality's sake. But yes, it was a pleasure doing business with you, and I will continue doing so. Peace.